Assalamualaikum and good day everyone. Okay, we will cover in this lecture a week 5, okay, which is the combinational logic networks. Okay, so we will cover the first part, okay, which is the min term, the max term, the canonical SOP and POS. Okay, so we will cover, okay, I will try to save the paper. Okay, just try very small here. Okay, we will cover the min term, max term, canonical SOP, then canonical POS. Okay, so I briefly discussed to you guys last time what is SOP, right? SOP is actually the sum of products. So you have product, okay, sum, okay. What about POS? POS is product or sum, means inside here is sum, here is product. Okay, this is for easy understanding what it is. Okay, so without further ado, okay, first let's read. Okay, canonical form, okay, Boolean equation, logic diagram and truth table may be used to describe the same function. Truth table, however, are unique. Okay, unique means you have 0, 0, 0, the output is what? 0, 0, 1, output is what? 0, 1, 0, output is what? Okay, logic diagram and Boolean equation are not. Okay, so remember, you can see here the difference, right? The truth table are unique, however logic diagram and Boolean equation are not. Okay, so this gives the designer the flexibility in realizing function. Okay, here because they are not unique, okay, we have the flexibility to realize the function, okay, for the design engineer, for example. Okay, a standard form of Boolean function is very useful for comparing seemingly different logic function. This is the standard or canonical form, which is the unique of each logic. Okay, two versions of canonical form are defined. Okay, so first we have canonical SOP. Okay, form, which is the equation Sn or of n term. Okay, and POS, product of sum, is the equation Sn n of r terms. Okay, so this you already see, right? SOP, equation Sn or, equation Sn or, you know or is plus, right? Equation of Sn or of n term. Okay, POS is equation Sn of or term. Okay, okay, understand? So this is your SOP, this is your POS. Okay, so then we go to the next term. Okay, we have, this one is quite easy, I hope you guys understand. Now we go to the min term. Okay, what is min term? Min term is the n term. Okay, is the n term with each variable present. Okay, which each variable present mean all variable present. Okay, this is the condition. Okay, all variable present. That means that if the complete is ABC, it should consist ABC, not only AB. Okay, and in either true or complement form. Okay, What is true? True means, for example, you have A, B, C, okay? Complement form means you have the use of bar, okay? Okay. Each minterm correspond to exactly one entry in the truth table, okay? Each minterm correspond to exactly one entry in truth table. For example, if you have a truth table of 3 variable input of A, B, C, okay, then you have F is the function of output. For example, if you take this row, for example, right? For example, just imagine. So this one is actually considered as one minterm. For example, okay, if it's result in a minterm, okay, it's only exactly one entry. This is means like one entry, okay? So what here over represent, like I told you guys, is A, B, C is a minterm, for example, and this one is not. Why? Because C is not present, the complete variable, okay? This one is all variable present. Okay, I hope you guys understand. And then how about maxterm? Okay, maxterm. Maxterm is the OR term, okay, with every variable present, the same as well, all variable present, okay, and it's either in true or in the complement, okay. The same, this one is the original, okay, A plus B, for example. And how about this? A plus B bar, okay. Let's say for this example, okay, for example, so we have complemented form. One of these is a complement, okay. Okay. Now, but this is OR, okay, so OR, so it can be like A plus B plus C, or this one is considered a maxterm. However, A plus B is not a maxterm. Why? We don't have C. You need to have all variable present, okay. So, and the same, similarly with minterm, for maxterm is only correspond to one entry in the truth table, okay. And then for the minterm, okay, for minterm, it says that for minterm, 1 means the variable is true, means not complemented, okay, and 0 means it's complement, okay. Don't worry if you guys don't understand, I will explain later. For the maxterm, however, 0 is true, okay, and for complement is 1, okay. Okay, you can see the difference, right? Okay, so we go to the example, okay, we go to the example. So I want to try to save the, we should save the earth, okay, reduce wastage of paper. So I try to use only minimize the use of blank paper, okay. So okay, here for example, if you have two input, okay, two input variable, what is the possible combination? You have 0 0, 0 1, 1 0, and 1, correct? Okay, so this is the possible all variable, okay, in these conditions. And how we actually going to derive, okay, what is the minterm and what is the maxterm for this case, okay. Okay, we try to see the minterm first. The minterm is consists of n, okay, should be formed like this, mean it should be A multiplied by B, okay. And then you see here it mentioned that 1 is considered true and 0 is considered complement. So you have C here, 0 is considered complement, so it's A bar, okay. And B is still 0, so it's complement also, okay. So this is considered minterm number 0, okay. How about this one? For the minterm, you see 0 is still 0, is considered complement. The min term is however the true. So this is your min term 1. Okay, remember it's an n. Okay, I just try to make this obvious so that you guys actually see it's n. Okay. Okay. How about this one? The same. Okay, so it's 1, so it's a, this one complement. Okay, so dot. Okay, there is no need for this dot all the time, but I want to show you the concept. Okay, it's actually n. So how about the M3? Okay, so the M3, you see both are 1, so A, B. Okay, so now we go to the max term. The max term is about OR, so we should have the combination in plus form, in addition. Okay, so you see for the max term, 0 is true and 1 is considered complement. So 0 is true. Here 0 is true, so it's A complement, and you see it's still 0, so it's B. Okay, so it's for the max term, okay, capital letter. Okay, you can see the difference. Okay, please see the difference of writing. Min term small letter, this one capital. Okay, then how about the M1? M1, you can see A is 0, is considered true, right? So it's A. Okay, and sorry, okay, this one is OR, so you can see it's a plus. Okay, so now the next plus, the next addition. Okay, so you see this is 1, it's the complement, so it's B bar. Okay, so we repeat until here. So this one is what? This one is complement. So this one is also complement. Okay, so you guys can try it home. So how about the true variable? The same. Okay, the true variable is just the same. Okay, just the same repetition. Okay, you guys can try. It's just an expand variable. Okay, you can have 4, 5, 6 and so on. You can even have 10. Okay, now we go to the next part. Okay, we go to the next part, which we consider as canonical SOP. Okay, now in canonical SOP is we need to list. Okay, list means we will need to list all possible. Okay, all possible combination. Okay, for this one we need to list the min term. Okay, list the min term. Okay, the min term, remember, is the min term where the function will result in 1. Okay, where the output will result in 1. Okay, for example, okay, we see from this graph. Okay, we can see from this graph. Okay, I try to okay, I don't want to waste the pages of the paper. Okay, you can see in the min term where is actually result the value of 1. Here, 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 and here. There are 4 combinations. Okay, so I just put it straight away here. Okay, so we try to save some space. 0, 0, 0 is result in 1. The other 0, 1, 0 result in 1. This one 1, 1, 0 result in 1, and 1, 1, 1 result in 1. Okay, so we just take the one that have 1. Okay, actually in exam you need to sometimes they require you to list all. Okay, this one is just to save the pages of the paper. Okay, so this is our the list that actually giving the function of 1. Okay, output of 1. So and then is a min term. What happened in min term just now? In min term, 1 is true and 0 is complement. Okay, so here, and min term is actually the n. Okay, the n of OR term. Okay, n of OR term. That's why you have sum or product. Okay, means we have possible combination in terms of addition for products, variable product in product terms. Okay, So here, for example, okay, here, A, B, C, right? You have A, B, C, okay? I just want to make you guys understand, okay? It's a product, okay? Product, so it's a product first. Now we need to see, is it all zero, right? All zero is complement, so, okay? How about this one? That gives the function of zero, okay? So you have 0, 1, 0. So 0 is complement, so you have A, B, C. The complement is this one, okay? And how about this one? You have also A, B, complement, 0 is complement, so this one. And then you have the last one, the last term, you have all 1, so it is A, B, C, okay? So this correspond to M0, this correspond to what, okay? We need to see where is the term realized, okay? This one is M0, M1, M2, M3, M4, M5, M6, and 7. That's why you need to list all, okay? I just want to save space, okay? So this one is your M2, okay? This one is your M6. Remember, small letter, okay? For the midterm. And then you have M7, okay? So, for function, for the canonical SOP that results in the function of output 1, okay? The result in output of 1, we have the combination of A, B, C plus, okay? Why we use plus? Because remember, it is sum of products, okay? Sum of product, okay? Then we have plus A bar, this one, just write directly. Okay, so all of them, this is plus, okay? Plus, 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 okay? Then to further simplify, okay, you can see function contents of variable A, B, and C, okay, which result in output 0 is actually M0 plus M2 plus M6 plus M7, okay? Then you can write in summation, okay, M of 0, 2, 6, and 7, okay? This is in correspond, okay? You can see here is very direct. I think nothing difficult about it. Okay, now the next step is to convert. We have, let's say we have this equation, okay? You want to convert them back, okay, to canonical form. Okay, we have this function, we want to convert to the canonical form, okay? So, okay, I just want to see, okay, where okay. Normally this one is, we try with the one that already simplified, okay? For example, okay, this one, the question is convert F A B plus A C bar plus B C, okay, to canonical form, okay? Sometimes it doesn't mention, okay, canonical sum product or canonical of product of sum, but here you can clearly see it's a sum of product because it's a sum of product, okay? Sum of product, okay? Now, before we even try to simplify, okay, let's try to derive the canonical form. Okay, you see here, we have AB, we have AC bar, we have BC. So we know actually there are 3 variables actually should exist, okay? But due to simplification, we only have 2 variables, okay? So to tackle this question, you need to expand first. To expand so that each of the term will have 3 variables each, okay? We'll have 3 variables for each term. So here, we will introduce the concept of, for example, that we will times by 1, okay? Okay, we see, sorry, AB times by 1 plus AC bar times by 1 plus BC plus 1, okay? You can see, right, anything we multiply by 1 will result in no changes, okay? Just similar, like AB times 1, you still get AB. So here, we will use the concept, For example, for this case, we want it to have C term, right? So we will combine with C plus C bar. Okay, this will result in 1. How about this one? We will put the B plus B bar. Okay. How about this one? We don't have the A term. So we have 1 equals to A plus A bar. Okay. So it's simple. So now we put inside, okay, we introduce, okay, because this is 1, this is also will result in 1, okay. Okay, so you have A, B, C plus C bar plus A C bar, B plus B bar plus BC, for this is A plus A bar, okay. Okay, all the orange is actually equals to 1. So we actually didn't change the by value, okay, because it's still 1. Now we extend it. We extend it A, B, C, okay. Now then we extend another one. Expand A, B, C bar. Similarly for the rest, okay, but we just arrange it so that it's easy. A, B, C bar plus A, B bar, C bar. Then how about this? A, B, C plus A bar, B, C. Okay. Then you notice, okay, then you notice you need to see there is sometimes a similar term. Okay, similar term we will omit, okay, because, okay, for similar term, for example, like in Boolean expression, in this you already study, right? Let me try to refer to the previous so that you won't you understand the law, okay. Remember that I asked you to try to memorize and understand the, if you understand you don't need to memorize, okay, but I hope you guys will prefer to understand than memorize, okay. Here you see A plus A will result in A. So no matter how much A that you have, will still result in A. For example, okay, if you have AB plus AB plus AB, so it's still AB, okay. So we use this concept. So I want to ask you guys, okay, which of these is actually have the similar term? You can see this one, right? This one is similar with this one, correct? Am I correct? Okay. Then which other have almost have the same the similar one? Then you have this one. Am I correct? A bar C, okay. This one is also correct, okay. So they are similar. Okay, if they are similar, you just make it into one. So the next, so this one is A, B, C plus A, B bar, C. Okay, and the other just follow. Okay, just follow because they don't have similarity. They don't have duplicate. A, B bar, C bar plus A bar, B, C. Okay. Then, okay, from the truth table that you know the possible combinations, okay, possible combinations, A B C is actually equals to what? A B C, where is all 1 is here, so it's actually M7. Okay. How about this one? 1 1 0 1 1 0, so it's M6. How about 1 0 0 1 0 0? So if this is your M2, M3, so this is your M4. Okay. How about 0 1 1 0 1 1? So it's here. So it's actually your M3. Okay. I see it is not in order. It's okay as long as you guys understand. Okay. Then plus plus plus. Okay. Then until at the canonical form we have the summation. Okay. The M term, min term, remember small m. Then we have what? Arrange in order 3, 4, 6, 7. Okay. So it's easy, right? Okay. Next, we will go to the canonical SOP, the canonical POS. Okay, this one you can try at home. Okay, example, proof that A B blah blah using canonical. Okay, I show you guys the pages. You can try to do at home. Okay, you fill it this and you try to prove. Okay, then you refer back to this module. If you don't have the module, you already see my video. Okay, so you can just refer back. Now, I'm not sure if we can use the same paper. I want to reduce. Okay, lately I've been using a lot of blank paper to teach, so it's not really saving the, we are wasting the resource. Okay, so now we go to the next one is the canonical POS. Okay, so what I taught you guys before, POS is the product of sum. So you have sum inside, product of sum, so something like this. Okay, so to make you guys understand, so the product of sum, so it's a product here. Okay, now it mentioned here that to derive the canonical POS, list the max term where the function is 0. Okay, now it's also the same. We need to list all possible combination. Okay, we need to list all possible combination. List all, okay, possible combination. The max term, okay, the max term. So you guys know why max term, right? We should write in capital M. Okay, where the function will result in 0. Okay, function is 0. Okay, and then we combine using n function. Okay, so this is logic. Okay, just like that, is combined using n function. You see here. Okay, so nothing surprise about that. Okay, let me see. If we to use, I want to see if are they using the similar page. Okay, so they are referring to the similar table. Okay, I don't want to waste. Jangan bazir kertas. Okay, just tulis apa yang perlu saja. Okay, so here, okay, we will take the one that actually will result in 0. Okay, you see what is the, anyway, for max term, what you learned just now, max term, for max term, for the true which is 1, right, complement. Okay, what is how they are written? I just trying to revise back. Okay, you see from the page here, for max term, 0 is not complement and 1 is complemented. Okay, it's, you need to able to distinguish, okay, between the max term and min term. So by the max term, true is considered complementary. Okay, and the complement is the true number. Okay, here 0 means the variable is not complemented and 1 is mean the variable is complemented. So the true here will be complemented and the not complemented will be 0. Okay, 0 will be as is, just like you guys see. Okay, you guys can play back to understand. Okay, play back the video. Okay, so here we will take the one that will actually result in 0. Okay, we see the combinations here. Okay, where is the result in 0? This one, right? A, this one. Okay, A, B, C. Okay, so you see the true will be inverse and this one will be 1, will be not complemented. So here you have result in 0. Okay, take this one, so it's 0, 0, 1. So here, okay, and it is a sum, a product of sum. So product of sum, so it is summation inside. Easy so far? Okay, now how about this one? 0, 1, 1. Okay, is 1, A plus B plus C again, but we need to assign, okay? So this one is 1, 1, so it's inverse, okay? And result in function of 0. Another one, this one result in also 0. So it is A plus B plus C, okay? But which is the one? Here. So it's only here, okay? The last one, they have the function of 0, this one. So you have A plus B plus C, okay? So you have 1, then this one, okay? So you see, this is the possible combination, okay? So this is actually equals to M1, okay? M1, this one your M0, right? This one is oops, where's my pencil? Okay, this one is M0, this one is M1, M2, okay? This one is M6, this one is M7, okay? So this one is, the next one is M3, this one is M4. I think you guys understand it. I just want to speed up, okay? Now, then we need to write the function of the max term, okay? In sequence, okay? We should write in sequence. I mean, the end result should be in sequence, okay? So, now we write F, okay? For the first combination, product of sum, okay? So you see you have 4 possible combination, right? Okay. Okay, so we just transfer directly. Okay, so it's quite easy. Okay, now you have this, you have that. The next one, you have to simplify it further. Okay, F containing the variable of A, B, and C. Okay, what is the corresponding max term? Okay, so you have this one is your M1. Okay, capital M. Okay, then you have M3, then you have M4, and you have M5. Why is like this? Because it's a product of sum. Okay, then the next, simplify further, then you have like this in this form. Okay, you have M, then what is number 1, 3, 4, 5. So far so good. And this one, okay, the conversion between canonical form, I will cover in different lecture. Okay, this is about don't care condition. Okay, so you guys can start doing exercise, okay, on your own effort in group. Okay, you guys can submit. Okay, you can make a new discussion at our forum. Okay, with regard to the exercise. Okay, I will want to see forum. We can see. Okay, we try to see. I want to see you guys can do until what stage. Okay, you can try first. It seems like where I want to see where is related using the don't care condition. Never mind, if you see something that you cannot do, it must be something that I didn't teach. Okay, I mean the don't care condition. Okay, now for the new discussion, you Hui, okay, Hui, please create new discussion with the title of module exercise, okay, chapter 5, okay, exercise 5.1 until 5.14. okay. So I know not all of you have the module. Okay, you guys can see the video. Okay, you guys can see the question. Okay, I hope you guys can see. Okay, I see you guys see 5.1, 5.2, 5.3, 5.4, continue 5.5, 5.6, 5.7, 5.8, 9, 10, 11, 12, okay, here. And this is 5.13, and this is 5.14, okay. please post new discussion, and the group leader, as always, they will try to solve in group. Okay. That's all. Okay. So please try to do all of this 5.1 until 5.14 before our next class. On Thursday. Okay. So I know it's a lot, but you guys that's why you are in the group, right? Okay. But you guys need to ensure that all of the members understand. Okay. Remember, make sure all of everyone everyone understand. Okay. So you can have you can put this on the Tuesday, right? Tuesday. What is the date of the Tuesday? Tuesday later on? It is 13, okay? Sorry, it's Monday, right? The class is Monday, 12 or 4. Then you can finish by the Thursday, if possible. If not, it's okay. It's depend on you. There's no, I don't want to force you guys here. You guys are university student, okay? But if possible, to do it fast so that you have more understanding. So, before the next class on the 15th, okay? Okay, try. Okay. So with that, we finish the lecture. So see you guys in the next class, which is about the don't care condition, okay, conversion and the rest. Okay. Assalamualaikum warahmatullahi wabarakatuh, and see you guys later.